So good day everyone, praised be Jesus and Mary. I am Shalame Mihurada, and in this presentation we will talk about the facilities for teaching science. So here are the contents of this presentation. First, the science room, the supply and equipment. Next is the essential materials in the secondary science room, and then the homemade laboratory equipment, and lastly the other equipment in the science room. First, um, science room. It is generally assumed that better facilities will affect the quality of education in schools. So in general terms, the evidence reviewed in relation to science teaching is consistent with the notion that students' physical environment affects their study behavior. It may urge, therefore, that attention must be paid to the provision of good teaching facilities if active form of learning are to be encouraged. So, the general accepted program of science teaching in secondary schools is conducted in a group of specialized rooms provided with special facilities and equipment. So the learning outcomes and teaching procedures in science are uniquely dependent upon the availability of these facilities. So teachers, laboratory assistants, and pupils devote a large portion of their time and energy in procuring, devising, organizing, caring for, repairing, and manipulating a vast array of teaching materials. So, to large extent, existing practices in science teaching, in so far as they include the use of their specialized equipment, are the result of analysis, research, and testing. So, next, there are 10 guiding principles in the science room. First, a science room is a place where the pupil may receive educative experiences which give better understandings of those generalization in science that contribute to the enrichment of life. So the emphasis here is on the word experience or the experiences. As here defined, the science room is a means to an end rather than an end in itself. So the room must make it possible for the teacher to set the stage that questions can be put to the nature and answers be derived through the observation and reason on the part of the students. So the second, experiences for which science rooms shall provide are justified by and take their origin from the prescribed program of science studies. So the practice based on this principle will avoid the teaching which is organized around facilities that chance to be available. So um, while the program of science studies tends to change more rapidly than building and equipment, it is possible to plan rooms and facilities in such a way as to make adaptations and change reasonably possible. So, third, a science room or facility must be evaluated in terms of the educative experiences which it makes possible. So, It is probably true that no necessary correlation exists between the cost of the facility and its educative value. Yet, it is often also true that um, teachers of ability and experience must devote a major portion of their energy to overcome handicaps due to the lack of property facilities. And number the fourth guideline principle is a science room must be a place where the experience in problem solving is possible. So the effect of this principle is not so much matter of the radical change in design and equipment as it is in attitude toward the use of organization facilities. It must make possible the exploration of student interest and capacities. So the fifth one, the design of both science classrooms and laboratories should provide facilities for the effective teacher and students demonstrations. So the work of many investigators has called attention to the value of demonstration teaching. So the demonstration teaching are essential to many types of learning in science. So many laboratory exercises can be more effectively presented as um, teacher or pupil demonstrations. In planning science rooms, therefore, um, considerable attention must be given to this activity. The size, position, the equipment of the demonstration table are matters of importance. The visibility, illumination, accessories, proper display, the convenience, time saving, and laboratory saving devices, and the avoidance of waste motion are all factors to be considered. So let's proceed to the sixth guiding principles. S- Um, certain science rooms should provide facilities for individual laboratory work. So, manipulative skills, resourcefulness, and facility in problem solving can come best from a teaching procedure which enable students to experience individually at least three types of activities must be possible in laboratory. So, first, exercises required of all pupils or students and requiring multiple sets of equipment which develop better understanding and skill in manipulation. Then second, the laboratory exercises from which students may select in accordance with special needs and interest. Then lastly, exercises originating in problems formulated by pupil or teacher. This problem may be modeled after some basic research or discovery. And then next, science rooms should provide certain facilities for objectification by means other than use of concrete material. So this guiding principle calls attention to such items as the blackboard, bulletin board, display features, charts, and specially referred to as the audiovisual instruction. So science room must include facilities for the operation of such devices as the motion pictures, radio, sound recorded, and production, and also television. Then next, planning of science rooms and their equipment should be a cooperative project in which the architect, the engineer, the educational supervisor, and science teacher each play a proper part. So, the experience and knowledge of each of these individuals must not be ignored. So, great saving in cost and increased efficiency in use can result from cooperative planning. Then, next, in schools designed for 1,500 or more pupils, the number enrolled in science courses and the number of science teachers involved are such as to require facilities that can best be administered by laboratory assistants. So since the teaching load of science teachers are usually the same as for teachers of other subjects, the science teachers must have the service of laboratory assistants. Then lastly, adequate provision for talented youth demands the um, special facilities referred to as a biology and physical science project rooms. So, while the elementary laboratory rooms and science recitation rooms will meet the needs in general education, the science project rooms provide an outlet for the interest of those gifted in science. The latter rooms must be so designed as to make creative work possible. So, in science, we are all about learning in a hands-on way whilst making discoveries and learning from challenges. These three learning tools are a big part of how things work in the science room. First is the tool set, using equipment and managing our workspaces correctly and safely. Next, the skill set, thinking like a scientist, which help us to form a hypothesis, making observation and draw conclusions. And then lastly, the mindset is reflecting on what worked, what didn't, and what could be improved upon. So next is the supplies and equipment. So the child's environment as it expands rapidly with new breakthroughs in science and technology offers unlimited opportunity for science learning. The new science publications are appearing almost daily for the use of students, teachers, and administrators. So the quality of the science program is related to the quality of facilities, supplies, materials, and equipment. Since these are the basic to a good teaching learning situation, they require special attention in the overall planning of science program. And then the facilities and equipment, of course, are determined by the type of science activities in the school program. So certainly, programs of science should be in harmony with the purposes of total program of education, which in the main helps students or helps the children gain values, understanding, and skills consistent with good citizenship in a democratic society. So each schools must define its own objectives before making decisions concerning equipment and materials. And then next, requirements pertaining to equipment and materials also vary for simple observations for which no equipment is needed to experiment or field study involving numerous items of different types. Then the role of teacher is to help the child discover facts and relationship for him rather than to tell him the answers, and to assist him in demonstrating principles by performing simple experiments for which suitable equipment and materials have been carefully selected or improvised. So, schools have a responsibility to provide children with the relevant equipment for subjects such as science and technology. Not only is this to ensure that they are safe while they are undertaking some potentially dangerous experiments, but is also allows them to get a solid, safe introduction to some fascinating subject matters. And here are what would consider the basics that every science teacher should have to start out. So first, the basic chemicals, the such as the glass beakers, plastic test tubes, goggles for the safety of the eyes, the thermometers, also, and the rubbing alcohol, the and also the bromothymol blue for the detecting presence of carbon dioxide, and borax also for the grade for crystal and making gak, and etc. Next is the science supplies for teaching biology. There are a wide range of concepts when teaching biology. These range from environmental science, plant and animal science, to human body systems. So, um, what we are going to have is the seeds for planting, grow light, of course the sun, the good posters of body systems, the stethoscopes, if you have one, the microscopes also, the plastic animals of all sizes, dissection trays also, and etc. So next is the weather equipment. It is great to take the kids outside and have them actually measure the weather. Keep basic, inexpensive equipment on hand so they can keep with their journal. So the the weather equipment are outdoor thermometers, ground thermometer, compasses, of course, the bubbles for finding wind direction, the psychrometer, which useful for the relative humidity, and also the cloud charts, and etc. So, the forces and motion materials. There are so many labs that you can do with balance and unbalance forces, speed, acceleration, and types of energy. Gather simple materials that can be used in many ways. So, what we have to um, ano is the pulleys, thin rope, the friction board, sandpapers, pullback cars for the great potential energy, kinetic energy, speed, and acceleration labs, and also the stopwatch, the meter sticks, tape measures, and balls of all sizes for the collision labs, gravity drop. And next is the magnet and electricity supplies. Students love playing with the properties of magnets and learning about the different types of circuits of electricity. So, um, the magnet and electricity supplies are batteries, flashlight bulbs, wire cutters, alligator clips, magnets of different sizes and strengths, static creating materials like fur, um, cotton, the wool, fabric, and balloon, aluminum foil. So next is the supply for studying lights. So the teaching about the electromagnetic spectrum and visible light is so much fun, and you can do lots projects with flashlight lenses and mirrors. So of course we have here the flashlights, mirrors, light bulbs, holders, and bulb spoons, and etc. And now let's proceed to the essential materials in a secondary science rooms. So first, is the physical protection, of course. Um, Although many experiments in schools are relatively safe, accidents can happen. Ensuring that students are safe and protected should be a top priority for any school, even if you believe an experiment is sure to go right. This means providing all students with safety goggles and lab coats when necessary, as well as keeping a stock of first aid kits, gloves, blankets, and eye washes. It may also be worthwhile investigating in safety screens at the students can work behind with ease, especially if there is a risk of chemicals or other harmful substances coming into contact with students while they are conducting an experiment. So now the next is the feminine products, of course, for the girls, and dry erase markers, anchor chart paper, pencil sharpeners, staplers, misc disc supplies, the dustpan gloves, the detergents for the hand washing, of course, the bottle brushes to clean glasswares, the test tube cleaning brushes, broom and dustpan, then extension cord, the power strips, doorbell for getting the students' attention, of course, when they are so noisy inside the room. And then next is dorm refrigerator is nice to have. Then sign out notebook for bathroom and office visits. Next is the homemade laboratory equipment. So the essence of science education is an involvement and understanding of the process of science. Therefore, the effective use of laboratory is a prerequisite in science education, as science is an experimental, observational, and laboratory-oriented discipline. So learning science should start with hands-on experiments that the students are familiar with, and not with the abstract definitions of scientific concepts. So, um, low-cost apparatus from locally available materials assumed to enrich the capacity to observe, explain, and do real science. So the significance of laboratory activities can be understood um, in light of the following four broad roles. Laboratory activities can be means of gaining basic laboratory skills, developing observational skills, the explaining a particular concept, and having best experience of what science is all about. And then um, the in here in the Philippines, um, there is a press release from the Department of Education in September 28, 2011. Um, According to Armin A. Lewis-Straw, the training is very important for the science teachers to master of the use of and application of the new science equipment, as well as the maintenance procedures to ensure the long-term use of these equipments. So, according to many scholars, the advantage of using low-cost materials can be summarized as the use of local materials makes makes teachers and learners aware of the resources to be found in their environmental and stimulates creative to use them. Then next, the experiments and models can be constructed in very short time with a few tools with locally available materials, even by unskilled person as part of pre and in service teaching out teacher training. Then the self construction develop a sense of proud ownership and promotes a more frequent use. And then repair and replacement of broken parts are possible locally without technical and administrative problems. So for the storage, no special storage facility is needed. A lockable cupboard is enough. Security is no problem because the low material value. So for the implementation, no special infrastructure is needed. The innovation goes straight to the schools. What has been learned today in a training workshop can be applied tomorrow in the classroom. So, in actual fact, science should taught in such a way that students are exposed to real and practical related activities according to Odyssean and Ikokinam in 2013. And science experiments help students to increase their self-confidence, creative creativity, innovation, imagination, and curiosity. They also contribute in the development of critical thinking skills. The hands-on experiments and practical activities in physics improve students' learning and also help practical skills development, problem solving, analytical skills, and positive attitude towards science, according to Daniela Popisco, Lone, and Andre in 2015. So, the other equipment in the science room is a September 28 in 2011, the press release from the Department of Education, um, the Department of Education has released some 330 million in producing science equipment, which was delivered to 435 public secondary high school nationwide to improve the students' learning and appreciation of science concepts and application. So according to Mr. Armin A. Luistro, training is very important for the science teachers to master the use and application of the new science equipment as well as the maintenance procedures to ensure long-term use of these equipments. So, and here are the lists of equipments, instruments, and science learning tools include for the integrated science, such as the aneroid barometer, assorted glasswares, the triple beam balance and terrestrial globe, seismograph model, the connecting wires, the magnets, alcohol burner, the ring and ball model, and also the magnetic compass, the thermometers, map of the world climates, map of the Philippine climates, map of the Philippine volcanoes, map of the stars, posters, layers of the earth, the Richter magnitude scale, and various consumables. And for the biology, we have here the compound microscope, dissect sets, the human torso models, the human skeleton models, the animal mitosis model, the assorted glassware, alcohol thermometers, the triple beam balance, of course, the glass slides, assorted chemicals, and then alcohol burner and safe glasses, the charts, of course, the plant cell, the animal cell, development of the embryo, and also Mendel's law, and the gene map of human chromosomes, food pyramid, of course, the and flower and seed structure. The next is for chemistry. We have here the alcohol thermometer, the assorted glassware, um, the Bunsen burner, and laboratory safety rules, basic laboratory apparatus, and etc. And for the physics, the open U tube manometer, the air blower, the light bulb and dry cell, the set of connectors, the resistance box, introduction of radioactivity kit, the switches, of course, and then the graphing calculators, the basic electronic kits, the fuse withholder, and loudspeaker, music instrument, basic lens set, and etc. And we have here our references for the report. Thank you and God bless.